Yeah. Well, I love the rust makes it really good. Yeah. Have you looked at Foundry? Oh, I love it.
Yeah, I'll grab them in a sec, but
Oh yeah. Well, now I have to use Hardhat. The Foundry's awesome. Because I was working, and this is a Java shell as well. I was working in Java shells, so like the Java experience is really just sucks. But if you can just run all your stats and everything in Solidity, I think that's perfect.
Yeah, trying to switch languages and testing. I did that a little bit, and I just
I hate it.
I'm like the big and it's it's such a waste of time. We're just wasting time on these tests. It's like, oh my god, I just want to go.
I know. Yeah, it sucks. It sucks because I had the satisfaction, even if I was stuck writing it fast in Solidity, I'm at least like ramping up and learning Solidity.
At least gaining skills versus just like fighting.
Fighting with TypeScript and ethers or something. I never thought ethers.js was intuitive to begin with.
No.
I don't know why everyone loved it. Whatever.
Oh yeah, even how they're like, it's like to me it's reversed how you're supposed to like, what was the function? It was the thing about like checking balances and approvals. It was like backwards.
Yeah.
It's like so counterintuitive. I got like bitten by that something.
Yeah, I'm back using Hardhat now. Yeah, whatever. I may be able to get them because they want, if they're interested when I talk to them about Foundry. So I may be able to get Foundry in there.
The last product I was on, and so like if people were more comfortable like hardware issues and then everyone
Well, the problem is, I ran into as well, is okay, Foundry is great. When it comes to doing the arbitrage bots, I'm going to need the interactions to like, I'm going to have to interact probably with an MEV API somewhere. So I will have to have some language. And in my last gig, it was just a Java shop. So like, okay, I'm just driving with that. So I don't know. That's the one more thing I can see in part about TypeScript. But
there's still people coming in.
anyway, I don't know. Like I said, there's just too much going on.
I'm like so overwhelmed with like, it's like I can't get things done now because I'm not doing it because I'm just like one day I'm like,
Yeah, exactly.
Take a step back, I'm like, oh my god.
Well, like I said, every time I find a new way, like a new node or new like something to run, like passenger. So I'm like, okay, just focus on that. Get that done, go do my day job, and I'll get back to the arbitrage stuff later. Because that's just gonna like those opportunities are just gonna run out.
There was one of those things that was like, and right at 6-8 people. I'm gonna try out, but honestly, like, I think that's what I was trying. And then the final piece was that
There should be something other than the same 275 level.
all the other time it's
Wow.
some sort of supply chain.
How is
Well, you're collateralized. Yeah, I'm paying money on the loan. JavaScript. I'm like, I don't think I like the idea of like study over. Yeah, I totally agree with that. I totally agree with that.
Alright guys, get started in like 2 minutes. Grab a seat, get settled in, grab some pizza, some drinks.
Stupid question. I mean, you're recording this, I'm pretty sure, right? And you'll make it available like through the meetup link?
Yeah, it's available on the meetup link. The stream link is up there.
Okay.
And so it's streaming right now, and then that stream will compile into a recording that'll stay on YouTube.
Okay. So, all right, I'll find the link somewhere.
Exactly, yeah, it'll be on there.
So I don't have to take those. But I brought my laptop with me.
Take it out.
You lucked out.
Also, is anybody gluten-free? Because I've got a gluten-free stout that I'm willing to share. Well, should share. It's 32 ounces. So.
Treat yourself. Hello, fellow you. Treat yourself.
As long as you do the
Yeah. That's like an old thing.
Yeah, I know. This is pure stock in the middle.
So like meme culture and stuff moves so fast, and I just can't. I love your own Reddit. It's just literally me to feel off of it. So like I don't know.
It's not nuts. It's just like talking about the issue for
They were starting on L6, which is pretty good.
Yeah, that's for writing the others.
Give this. My mom got mad at me one time because I went on her eBay account and I didn't buy anything, but I just like added her favorites. And there's like every listing of like everything was like cool, add to favorite, add to favorite. And she went to her favorites and it was like all these. She's like, what?
Yeah, I did that with actually one ahead and wait. Oh my god, yeah, they're like recording my ass so hard. It's like an 8-year-old.
All right, Alex. I think we're ready. Yep.
All right, everyone, thank you for coming out. Sorry the pizza was late. I went on vacation for 3 weeks and forgot what time we started. But we're here now. We have pizza. Please eat lots of pizza. I can't take this pizza home. So eat it now or take it home. Preferably eat it now because it's delicious. Quick just show for the sponsors. Cryptorado bought the pizza, the beer, and always popular LaCroix. And Bulla Network. Cryptorado is just basically a community, most people I think know it, but community organization for a bunch of different crypto kind of stuff. There is a Discord that you can join and just be plugged into what's going on around here and talk to people. And the meetup.com page is a great place to just see what's going on. There is a Thursday just happy hour over at Seedstock this Thursday at 4:30 p.m. Good times over there. Space is provided by Bulla Network. Colin works for Bulla Network, so he gets to show Bulla Network and then lead us into what we're doing today.
Yeah, for those of you who have been here before, Bulla Network is the protocol that I work on. It's a on-chain accounting and commerce protocol. So you can use our product right now to handle payroll from your DAO. You can do a whole bunch of different stuff with invoicing and just cataloging ERC20 transfers, things like that. We're looking at releasing some more features soon for like peer-to-peer lending, but yep, that's Bulla Network. Big thanks to Dan and the folks at Cryptorado. Thanks guys for your flexibility here. With we're in a little bit of a different space than normal, but we're rolling with it. We're being flexible, so hopefully everyone can see the screen size here. Especially once we get into code, just shout at me and I'll make everything a little bit bigger here. All right, any other thoughts or comments before we jump in? Cool. All right. So this deep dive, we're going to go into Gnosis Safe. So who's at least just like familiar with Gnosis Safe? Cool. Who has used a Gnosis Safe? Is like a signer on a safe, done stuff like that? Okay. Less so. Cool. Great. Yeah. So quick introduction on what Gnosis Safe is. It is a multi-signature wallet. So normally, when you have like a MetaMask or something like that, you will sign a transaction and it will go out to the blockchain. This is like a smart contract wallet with multiple signers on it. So it has kind of some added functionality that we'll talk about. It can do cool things like batching, which a normal like Ethereum account can't do. It can require multiple signatures up to a certain threshold. So say like I have 5 wallets who are on my Gnosis Safe. I need 3 out of the 5 of those wallets to sign off on a transaction before it gets executed on the blockchain. So it's used primarily for DAOs, DAO treasuries, or for people who just want to have like a little more safety. So if you need like, you'll just need an extra signer, right? So say if you had like a hardware wallet and your MetaMask wallet, both as a signer on a Gnosis Safe, if you lost the keys to either one of those, you would still have access to your account. So people use it for their own personal use. They also use it for things like the DAO treasury and the like. So I use this repo, or I use this slide deck for a talk that I gave online. So you guys know me, no need to intro, but specifically here, I have 2 repos listed. So I have a repo for this talk because I did some work to make a flattened version of the smart contracts. And then I also have a repo. Let's see, where'd my slides go? They just disappeared. Seriously? Yeah, wow, all right. Safe talk. Hold on. Yeah, we'll try that. Yeah, and then secondly, I have a repo that I released recently that has a whole bunch of wrappers to do testing with Gnosis Safes in Foundry. And so I'm gonna like shill that a little bit. But all in all those links here are in the meetup. So in the meetup, I posted in the, I can't see the comment section because I'm not logged in. Damn it. There we go. Yeah, there's the stream link and the HackMD link, both in the comments of the meetup that you can go back and check out anytime. Yeah, and so the stream is going, so there will be a recording of this, and here is the HackMD. We'll add stuff in here as we work through the repo, but here's both the repo links as well, and we'll 403 shoots. That's because I have to go share, and I have to say read permission for everyone and write permission for everyone, and that'll be public. So anyone, if you have any cool repos or code snippets related to Gnosis Safe, throw it in this HackMD, and then like by tomorrow, I will just do like read only, but anyone can write in this HackMD for the period of the meetup specifically. Cool. So those are the repos. Yeah, so we'll talk about like safe features, and then the safe ecosystem, and then the contract deep dive. I wanted to do Gnosis Safe because it is it's a very like complex and difficult to understand repo. The structure is really wonky. They use inheritance like crazy. So like the base Gnosis Safe contract inherits off of like 10 different contracts, and it's really hard to figure out what's going on. So that's kind of the part, hopefully the goal of this talk is just to kind of demystify how some of the parts of the safe work, do like a contract deep dive, do an overview of the ecosystem of the Gnosis Safe, and then go over some of the features as well. So to talk about like some of the features of the Gnosis Safe, first, like it can execute any arbitrary transaction, either to other contracts or like execute a transaction to itself, like a transaction that modifies the signers or the threshold. It can generate valid EIP 1271 signatures. EIP 1271 is a standard that defines how a smart contract says that a valid signature came from it. So like normally when you and I have accounts on Ethereum, there are two different types of accounts. There's what's called an EOA, which stands for externally owned account, and then there's a smart contract account. And those are the two different types of addresses you'll find on chain. Smart contracts can't arbitrarily sign messages cryptographically, but there's a EIP standard that says how you could query for, like, given a bytes digest, is this a valid signature? And so that's a standard. So it can generate like signatures as well. It can validate, and it has like different ways of validating these signatures. So through like, you know, the ETH sign algorithm, EIP 1271, EIP 712 signatures as well. So it has all these different signature encoding and decoding algorithms. Another thing that it can do is it can refund transaction executors. So anyone who executes a transaction on a Gnosis Safe, given a valid amount of signatures, can get like a refund for paying the gas to do so. It can install what's called modules that bypass signature validation, and also install guards that do like arbitrary checks before and after every transaction. So we'll talk a little bit about like the Safe ecosystem. This is going to be kind of hard to see on this screen, but between these slides and the repo, I hope that this will kind of be like a reference if you ever have to like use Gnosis Safe in like any kind of production environment. You can kind of get a sense of like how their repo works. So kind of first off, we have like a Gnosis Safe proxy factory, and so that's like the entry point. When you go and create a Gnosis Safe, you're asking this proxy factory to go and create all these little smart contract proxies, and these proxies themselves will be the address of your Gnosis Safe. So when you go and create a Gnosis Safe, what it will be doing is it will be going to the Safe Proxy Factory and generating these safe proxy.sol, like it's like a small compact footprint because the logic for Gnosis Safe is pretty immense. So what it will do is it'll create like a little proxy for you that is much cheaper to deploy. So you'll get one of these when you go and create a Gnosis Safe on the Gnosis interface. And if you attended like the last talk, we know that like a proxy is a minimal contract that delegates to another base contract for all of its complex logic. So there are two singletons in this ecosystem. One called Gnosis Safe and one called Gnosis Safe L2. If you're ever curious about that, Gnosis Safe L2 just inherits from all the base functionality of Gnosis Safe, but it also emits events to make it easier for like indexers and other type of like indexing services like the graph to like understand what happened during a transaction. There's also a compatibility fallback handler, which is deployed as well, which we'll talk about that. And then there's some utility contracts like multi-send and multi-send call only, which allow you to do cool things like transaction batching. And then we have these different safe plugins that we can install. So we can install a module. A module will bypass our multi-sig functionality. So basically, like it has like super user privileges, so you can kind of define any sort of like logic you want on a module, and it immediately has super user privileges, so it can bypass any sort of multi-signature verification, but it's all opt-in. So if you deploy a Gnosis Safe, you're never going to have a module pre-installed unless you had that as initialization parameters. Next is you'll have guards. That's like a check that happens or code that's run before and after execution of every transaction. So you can install one guard per Gnosis Safe. And then next is a modifier. And a modifier plugs into a module. It's just like another layer of composability that will check transactions before they're executed.
Do modules have super user access? Because basically you're going to set up your multi-sig to tell the module that you want it to do its thing, and then it needs to do it, or why does it have super?
Reverse direction. So you could have you could install a module that allows anyone to execute a transaction under a certain circumstance, right? So maybe you release your own token called Colin token, and you write a module that says, like, hey, this Gnosis Safe is mine, but anyone with a balance of greater than 150 Colin token actually gets to be a signer on the safe anyway, right? So it's like it's completely customizable. You can just write in you can write in whatever. But yeah, so to talk about like the life cycle of the smart contracts and how they're used, we'll just go through this stuff a little bit quickly, and maybe we can hop into some code too, because I know people like to do that. Stop me if you have any questions about the code, because I know this crew likes to dive into code and ask questions that way. So kind of the first like life cycle, following the life cycle of the smart contract, how you'll start to use Gnosis Safe is via the setup function. So the setup function kind of sets up the owners, like the signing threshold. It sets a fallback handler, and it can also like arbitrarily modify its own storage by making a delegate call to the to param with a data param. So you'll see this to param here, and you'll see this data param here. This is like an optional initialization step. So what you can do is you can specify like a to address and data, and it will make a special call kind of on the initialization in order to maybe set up something custom about your Gnosis Safe. It also has these last three here. These last three parameters in the setup function handles the payment token, the payment amount, and the payment receiver. So you could refund someone for deploying a Gnosis Safe as well. This is all part of like the Gnosis code for the setup function. So as we can see, this calls setup owners. It sets the fallback handle if there's a fallback. It sets up modules. So you would use the to in the data field to set up like any modules on initialization, and then it emits like it'll handle payment if you specify like a refund, and then it'll also emit an event to that signifies that the safe was set up for any kind of like indexing. So yeah, like I said, for possibilities here, like you could set up custom modules, you could set up a transaction guard, you could actually like pre-approve n amount of transactions to be executed at any time. So you could like you could set up a Gnosis Safe with like preloaded transactions in it. You could do cool things where you could spin up like a single-use DAO, so it starts like a timer on initialization and can be self-destructed after a certain amount of time. So you could be like, okay, like here's a DAO address, and what we want to do, like we have like this mission, right? And if we don't accomplish this mission, like the DAO will be terminated after 8 months or something. So you can do all sorts of crazy stuff here. Basically, you can execute any arbitrary transaction or callback on initialization. So like Gnosis Safe is super flexible, and not a lot of people have like written functionality for this yet. It's not really written in the contract yet. Yeah, and then I said note, like all these features that I list here as like possibilities would have to be written into a smart contract itself that would be like delegate called on initialization. So like the next part, like once we have our safe set up, there's this function exec transaction, which like anytime you go to the Gnosis interface, it uses this exec transaction function to actually execute these transactions. So we see some basic parameters here, like the to, the value, that would be like the value in Ether that you want to send. Any kind of like call data, right? So if I'm doing a transfer from, I'm going to pack all my transfer from data into that data argument. I've got operation, which either is like a call or a delegate call. So like I said, like a safe can perform just like a normal arbitrary call, or it can do a delegate call, which means that like it allows the contract that's receiving the call to modify its own storage. Also, it has like these next four fields here: safe, TX gas, base gas, gas price, gas token, and refund receiver, all have to do with like with gas refunds. And I believe that's not even implemented on the Gnosis UI yet, really, where like you can receive a like an Ether refund for the gas that you've sent. So there's like, I think they're using like maybe like 40-50% of the functionality that's baked into the smart contracts on the UI so far. So there's a lot of cool ideas that can be built off of Gnosis Safe. So yeah, you've got these two functions, exec transaction and exec transaction from module. So exec transaction from module is what would be called from a module to bypass the multisig, right? If you notice, like the signatures aren't passed in. They're not passed into the smart contract on the call. So yeah, any thoughts? I should probably slow down a bit. Any thoughts or questions on this before we move on? Yeah, so there's, so notice like in exec transaction, it accepts like a byte array of signatures because these signatures need to be validated in the smart contract. In exec transaction for module, every module has super user ability, so it doesn't actually need to verify any signatures because like if the sender is a module, then it will know that it can just exec that transaction. Yeah. So just like an interesting note here about transaction encoding, because like, just to give like a bit of context for how like Ethereum transactions are encoded in general, when I send a transaction like from my MetaMask wallet, what I'm doing is like my MetaMask wallet is just a private key, which means it's like a very, very large number. And using the ECDSA algorithm, what it will do is it will create a cryptographic signature around the hash digest of some data, saying that like my private key, which is held in secret, signs off on the fact that like basically I'm like signing this data. And then if like an Ethereum node receives that data and that signature, it can verify that that address actually like sent that transaction. So like normally like when you and I send in a transaction on the blockchain, it is a from address, which would be my wallet, a to address, which is like, you know, whoever I'm sending the transaction to, a value, so like the value of the transaction, so I can send like 1 Ether, right? And then also in addition to that, I sign the gas limit, so the maximum amount of gas I'm expecting to pay on this transaction, a maximum fee I'm willing to pay as a priority fee, and then the nonce of my wallet, and then also the chain ID of the network. So all those things are hashed together, and then I sign that with my private key. So like how a EOA transaction is, it's going to be RLP encoded and hashed to a 32 bytes value, and then signed by my private key. And so when I create a transaction on Ethereum, when I broadcast that transaction, I pass this data as as JSON to an Ethereum node, and I also pass the signature. So like my private key signing off on that data. And if the recovered signature, the recovered address from that signature matches the from field, then the Ethereum blockchain will know to like propagate that transaction because I validly signed off on it with my private keys. So like, yeah, go ahead.
What does RLP encoding actually do? You know?
I don't know the actual algorithm. It's reversed.
It's like relative link.
Reverse.
Key.
Yeah.
But it's for isn't it like how the linking in the state tree is? It's like where it's located in the state tree, right?
You know the answer?
Yeah.
Okay.
Yeah.
Interesting.
So it's like as it's encoding it, it's like this is where this links, like this transaction, like how to find it
Oh.
in the state tree.
Oh, cool.
Yeah.
Yeah, I thought it was a way to. I thought it was just a specification for concatenating like data.
So you cap the data and then it ends up.
Mm.
And it basically, because the state trees are put, Trisha tried, if I remember correctly.
Yeah,
I'm trying to remember.
that sounds right.
I think it's all out of, for what it's worth, the Gavin Woods yellow paper on Ethereum is the go-to that holds details. But the RLP, I think, is actually encoded the information.
Gotcha.
And then it's taken into the state tree, which is the particular trash.
Interesting. Okay, so for those on the stream, we were just talking about RLP encoding, and it seems like I don't know the specification, but it seems like it is both a way to concatenate the data that will be hashed together into a digest and then signed, and then also a way of like how to find it within the Patricia tree. Cool.
And you can also read more, I think, just in the Ethereum docs. There's a
Yeah. The actual details are in the yellow paper, of course. Cool. So what this transaction encoding algorithm like does for us is it protects my private keys from doing a few things, right? Like my address on Ethereum is just like backed by a private key. And there needs to be a few things that are hashed and like signed in each transaction in order to do a few things. One, to not like overspend like crazy the amount of gas that I have in my wallet. Two, to not grief my transaction. We use a nonce to not replay my transaction. And we use a chain ID to also not propagate my transaction across other blockchains. So basically, it's a way to say, hey, me as a private key, allow this thing to happen once on this chain with this amount of currency from here to here, right? And because like anyone could just take and reuse that data if these things weren't signed cryptographically otherwise. So like when you think like if you're creating a new standard for how like a smart contract wallet works, you would have to also create a spec for how a transaction is signed here. So this is how like a safe transaction is encoded. It's different, obviously, but it gives you the same guarantees. So it gives you this, there's a two, there's a value, there's a data. But in the case of a smart contract wallet, we can do either a call or a delegate call. So there's an operation enum. 0 is for call, 1 is for delegate call. There's base gas price, and since we can do refunds here, there's also a gas token, a refund receiver. Every safe has a nonce as well, which is identical to my EOA. There's a chain ID also, so that my transactions on Gnosis Safe on one network can't be replayed on a different network. And then instead of the from address, it's just safe address. So like just for some context, there's this own structure of transaction encoding, and I think the method on Gnosis Safe is get TX data, where you pass all these in, and then what it will do is it will give you back the hash digest of all those things in order to be signed upon. So like when you sign a transaction on Gnosis Safe as a signer, you are signing off on the hash digest of like what this Gnosis Safe will do in this proposed transaction. So in this case, instead of RLP encoded, safe TXs are encoded to the EIP 712 spec, and they're Kachak hashed, then signed by an EOA, or marked signed as an EOA on chain. It's up to you depending on how you want to sign. But so yeah, that's kind of, and when we combine this signing algo, we understand like how signature verification works. This is super cool. So they do a whole bunch of crazy stuff. We can look at the I don't know if anyone's interested, but we can look at the code here. So if we go to Gnosis Safe and blow up this code here, and we go to verify. Oh no, it's exec transaction, encode transaction data, check signatures, check end signatures. Yeah, so here's the method encode signatures, right? So what they do is kind of how signatures in Ethereum work is it's 65 bytes total. V is going to be a single byte, like recovery value, and then R and S relate to the I don't know, my knowledge of ECDSA is like falling short here, but they relate to the, it's just like you ask for a 32 byte private key to sign a hash digest, and in the ECDSA spec, you will get a 32 byte R and a 32 byte S value that can be used to recover that signature, to like basically check if that person is validly signed that with their public key. So like there are 3 different branches here. There's a branch for, and they do a whole bunch of encoding. So normally in the Ethereum spec, the V is going to be within the, the V value, the recovery value is going to be like 30 and above. Since it's, since this value is 1 byte, it represents the number 0 to 256. And so this is just like a special recovery value for each one of those transactions. But they also have created their own domain-specific encoding for a signature. So like if V equals 0, then it assumes that it's a smart contract signature, like an EIP 1271 signature. And that actually the address is packed into the R value. So if you see here, it like kind of extracts that that value there to get the owner, and then it does a is valid signature call, which this is the EIP 1271 spec, to like call a smart contract and asking if it is if it's a valid signature. So that's pretty cool. And then if you encode it as 1, it is interpreted as an approved hash, which means that like I can actually sign these things on chain. So I could create an on-chain transaction that like makes a stamp that says like, okay, me as this signer, I want to sign off on this transaction, and it stores it in a permanent storage. And then like the rest is, I guess if V is greater than 30, then it considers it to be an Ethereum signed message. And then, so I was wrong. 27 and 28 are the common, are the standard V values for like smart contract for ECDSA signatures on Ethereum, and then you just kind of use the normal EC recover function if you've ever used signatures on Ethereum before. So like there's crazy amount of functionality packed into this check signatures function that allows you to do smart contract signatures, that allows you to do like legacy ETH sign transactions, that allows you to do approved hashes as like a backup, and then just like kind of the default, like whenever you use this through the Gnosis Safe UI, you're going to be using kind of this flow here, which uses this whole like EC recover flow, and your signature is going to be like either like a 27 or 28 value. Yeah, so that's a bit of lore here, and this is just a reference sheet for that, right? V equals 0, 1 equals approved hash, which is an offline signing method. V greater than 30 is ETH sign. Otherwise, it's like a sign type data call, which is like the EIP 712 spec. So like if you've ever signed a Gnosis Safe transaction, you'll see it's like, it shows you in your MetaMask wallet, it's like to, from, value, data. And you actually get that verbose signing of all these values that you see in here. So it kind of gives you some like protection. I wanted to mention like, this is super cool. So this is a signing algorithm that can be used for any sort of like signature recovery when you have like an array of signers. So like say I wanted to say that a group of people signed off on a transaction, I would take an array of their signatures. But then you quickly, after looking at the code, you realize, well, what if I get a duplicate signature? And well, what if I get a signature that from someone who's not a signer? Well, what if their signature actually fails, right? What if it's an invalid signature? It's a corrupt signature. And this line of code handles all of that. And I'll show you why. So here's what the code does in the validate end signatures function is, first of all, what it does, so first pass through, first loop, it sets the last owner to address 0, right? Then what it's going to do is it's going to recover. Well, I guess I didn't show this in this piece of code, but one second. It's going to, yeah, here we go. Here's last owner. So last owner is 0. Then it's going to say current owner, right? What it's going to do is it's going to recover this signature. And when you use EC recover in Solidity, you pass a data hash and a deconstructed signature, the V value, the R value, and the S value, and this will spit back an address. So if we see the function signature here, it says returns address. So this is how you verify signatures within a smart contract. So basically, if I as an owner sign off on a transaction and I pass my signature into a smart contract, then whatever this EC recover function returns should be my address if I generated a valid signature. So what it does is it memoizes current owner within this for loop. So say my address ends in 0x89 or something, right? It'll then set current owner to 0x89. And then it requires that the current owner is greater than the last owner. So let's just talk about that real quick. This algorithm is super weird, but I love it because I've had to do multi-sig stuff before. So if EC recover, if this data hash and this signature is invalid, this function will return address 0, right? So if address 0 equals address 0, this fails, which means it's an invalid signature. If I pass my own signature twice into this function, if I try to create a duplicate signature, it'll be 0x89. So it'll set it here 0x89. Remember that Ethereum, hexadecimal code, they're just really big numbers. So your address on Ethereum is just a big number. So if current owner memoized from the past iteration was 0x89 in memory, then when I hit this again with a duplicate signature, I will get 0x89 again. And since 0x89 as a number is not greater than 0x89, the previous memoized value as a number, then it will fail. So this single line of code here sneakily protects you against duplicate signatures and invalid signatures and forged signatures and signatures that from someone who isn't an owner on the Gnosis Safe, all in one line of code. It's such a clean algorithm. It's super beautiful. Because normally what you would have to do is you would have to do a double for loop. You would have to iterate across all the signatures that have already been done to see if there was a duplicate every single time you verify a signature.
But how do you guarantee, how is this guaranteeing that if you have two pieces of data that are signed, two different
Right.
signatures are valid,
Right.
how does it, why would the lower address be first?
Boom. Yes, that's it. I'd love to hear that. So the question is for the stream is how do you guarantee that the lower address is the first signature and then a higher address as numerically is the second signature? So Gnosis Safe enforces you to do that computation off chain or within your smart contract. So they say, hey, it's really inefficient for me to do double for loops and check for duplicate signatures. So you need to sort your signatures by computed address off chain in ascending order. So that's exactly right. So you take your and the Gnosis Safe SDK does stuff to help you out with this. This is super easy in JavaScript too. You just take the address, you convert it to a big number, and then you do a less than call against the other address, right? And so you just say like, hey, this signature here is from this person, and then you just sort them in array ascending order.
But
So
you have to do that. It's the public address.
the public address,
So you-
correct.
So, all right. So just as long as you do that before it's passed in for whatever's been signed, you.
Correct. Correct.
How does the Gnosis Safe know that you did that validate?
It actually doesn't care because it'll fail either way. It won't give you like a nice error message of why it failed, because you'll just like, and you've probably hit that if you try to make anything custom. Is this GS062 a 026 error? Because probably because you weren't sorting your signed messages beforehand. So yeah, it's that's it. So you just have to sort them in ascending order beforehand.
And that's because nested loops are completely inefficient gas-wise.
Super inefficient gas-wise, and so when you're making smart contracts, right? You're thinking what's the minimal how can I just use the blockchain as a resolution layer to just cryptographically verify that something minimal is supposed to happen, and then push as much work as I can off chain, right? And so that's they really took this to the extreme here. But yeah, and so after they do that verify call, then they memoize that value for the next call, right, outside of the for loop. So big fan of this algorithm, super sick. And once it clicks, right? Because you're oh, an Ethereum address is just a number, and if you use this, it protects against so many little edge cases. Pretty cool. Any thoughts, comments, questions before we move on? Cool. Yeah, so if the signatures are valid above threshold, then the transaction is executed. This has a require function here, so it doesn't execute it in this function. It just will either revert or fail. Yeah, the next part of the life cycle is a guard check. So the safe delegates execution flow to a guard. I'll show you what this looks like here, right? So if we just pop back up the execution flow. Yeah, so this is the exact transaction function that we were talking about. It gets this encoded hash data, and then it increments the nonce, and then it checks that hash to make sure that all the owners in the signature array have signed that. So basically, if we get this far in the code, it means that we have valid sigs, and that we're good to continue execution. So it'll load a guard, your transaction guard, and it'll say if you have a guard installed, then it will check the transaction before execution. This is a weird piece of Ethereum lore that basically says you need 1/64th of the amount of gas that a transaction has. You need to save that in order to to emit an event that says that transaction failed without it panicking. Super weird. But so this is kind of where the transaction will execute, right? So it executes on line 177, and it just passes everything to this execute function, which simply handles either the call or the delegate call out of the safe. And one weird thing here, just to note, if you're ever using this or kind of rolling your own transactions here, don't specify safe transaction gas or a gas price if you want the transaction to succeed. Just let Gnosis Safe kind of handle that all itself, because if you do, it'll silently fail versus explicitly fail. So this is like a weird or gate that'll like fall through. It'll say like, hey, the transaction can require that the transaction succeeds unless you're doing like an estimation or you've specified some sort of refund receiver so that they get their tokens back anyway, even though the transaction failed. So you'll get like weird false positives. If you've specified a gas price, so like if you have said that like this person deserves a refund, then it'll pay the refund receiver, and then it'll emit an event, an execution success event, and an execution failure event, and then finally it'll do this final guard check after execution as well. So back to guards, right? Checks will happen before and after execution. So like if you think about that and you have like a cool use case for a Gnosis Safe, it's just a cool way to hijack the execution flow before and after every single transaction. So you could make like an accounting module that actually documents every single transaction on Gnosis Safe by like parsing the data field or by emitting some on-chain event, maybe emitting an event with a contract called poster, things like that. Yeah, so that's a possibility. And guards, when you delegate the execution to a guard, the guard is expected to revert. So I've got some examples here of some different guards. This is in the safe. So there's like a debug transaction guard. There's like an only owners guard. There's also like a reentrancy check guard, which will keep you safe. And so like, these are just examples of different guards. If you need like, if you have like a ton of tokens and people aren't checking transactions, you might want to put a guard on there just to like ensure that any malicious transaction might just explicitly fail and without like trusting your signers. Yeah, so this is the code for the execute function that we talked about. So it'll simply like execute a call to another contract or a delegate call. So it'll say like that's that enum operation. So like there's a call or a delegate call, and then it uses low-level assembly to load in the call data from memory, and then it will like save the success variable and just return the execution. Note that like if you're ever using a multi-sig transaction, that needs to be a delegate call. Okay, so that's the whole kind of execution life cycle of us like deploying a Gnosis Safe and then us like executing a transaction. Does anyone have any like questions before we move into like some of the stuff in the ecosystem, that like some of the ecosystem contracts?
Yes, like when you go to deploy a Gnosis Safe, I guess the thing I missed is like where does it actually, like what contracts actually get created? Is it just the, I forgot the name, but
yeah,
what does that look like?
It's the module proxy factory.
Oh, that's right. Okay.
Yeah, so it's the Gnosis Safe, sorry, not the factory. It's the Gnosis Safe proxy.sol. So like, I'll pull up the Gnosis Safe. Yeah, actually, this is a good time to just go over this Safe Talk repo that I have. So in this source file, I have not only do I have the slides in here, but I also have like two files in the source file. I have a flat safe.sol and a safe creator. So normally when you look at the safe contracts, this is the safe contracts repo, you'll have under contracts, Gnosis Safe L2, and then all this stuff buried in like the proxies, the libraries, interface handler, and Gnosis Safe L2, and Gnosis Safe inherits off of like this many transactions, this many contracts. So it's really hard to figure out like what is actually in Gnosis Safe. So I did some work to make like a flat safe file, and it's like a really clean and nice, and it compiles to, it just is it has all the interfaces in here, it has all the constant values, it has this contract called flat safe, which has the storages, the storage of the contract in like incremental storage slots based on inheritance. It has all the events, and so this can be like a reference for you to just like control F into, like it's like what methods can I call in a Gnosis Safe, every single method you can call is in here, including compatibility fallback handler stuff. It's all in here as well. And so this flat, kind of how Gnosis Safe works is they took all this logic here. It's huge, right? Gnosis Safe is like, yeah, it's like 800 lines, right? And what they did is they spent like all the gas to deploy that at one fixed address that they call the master copy. And that master copy contract contains all the logic for how a Gnosis Safe should work. And then what they do is they take the Gnosis Safe proxy. Your Gnosis Safe, when you go and deploy one from the UI, is just this contract. So it is this Gnosis Safe proxy. This is the address of the singleton, so like singleton, master copy, kind of interchangeable. And so what you do is that you just deploy this safe proxy and pass in the address of the singleton. And then this becomes your smart contract. It handles every single call through this fallback function, if you remember from like the last meetup, which just interprets every single call that happens to this contract. What it's going to do is it's going to load the singleton address from storage. It's going to load the call data from memory. It's going to then perform a delegate call to the singleton with all that call data. So it's just forwarding the call onto the master copy and then like returning the data to you. So you get your own address that has its own storage and its own token balances and things like that, but it forwards all the logic, all of its call requests to the master copy in order to like understand how to interpret calls. So like when you go, if you observe a transaction you made on chain, it will be most likely a call to this function here, because this is the proxy factory. This is deploy proxy with nonce. So you pass it like a nonce or a singleton or something like that, and like an initializer, and it will do like a deterministic deployment to that Gnosis Safe. It will create like an address for you. Yep. And so your Gnosis Safe is just this small bit of code, and that's why it's so cheap. Because you're not actually deploying that logic yourself every single time. You're just deploying this small proxy that forwards its requests to that master copy. Yep.
Address of the master. Sorry, I didn't look close enough there. What's the address of the master copy? Hard-coded for it to find.
So, how like Gnosis sets up their deployments on every network is they first deploy a Gnosis Safe proxy factory, and then they use that Gnosis Safe proxy factory to deploy these proxies. And they'll actually, sorry, I'm wrong. I think they'll deploy the singleton first, and then they'll deploy the factory. And then, if you go to like Gnosis Safe docs, in their documentation, they'll have, I think under their maybe resources. Nope, that's faucets. Different ways of create a safe. Core SDK. Nope. Their docs are notoriously like they use inline comments as docs. They hardly have any docs. It's like it's not fun at all. It's yeah, right. I guess so, man. Dude.
How much gas would do you know, like how much gas this code costs to deploy?
I have no idea. It's probably quite a bit.
It also depends on like what.
Let's see if Google's smart enough for this. Verify. Yeah.
That's number 2 search result.
Yeah, that's the master copy of version 1.1.1. We're at 1.3.0 at the moment with plans for 1.4.0 on Discourse. But anyway, yeah, I guess this is the address of 1.1.0 on Arbitrum. So if you wanted to, no, this is Etherscan. Never mind. Yeah, but yeah. Anyway, so there's the master copy there. I guess if we looked at the safe back. Yeah, that's a good point. Did it just take me to what a... is, interesting, huh?
I'm pretty sure you can search by name and filter for, I think in the more maybe.
Nope. Well, anyway. I have no idea where it is. So thanks, Gnosis Safe. They gotta work on their docs. I think I had like an example of a transaction. Whatever. But, oh, it might be in their safe contracts library, actually. So we go to save contracts. Developer portal. Singleton factory. Yeah, nope. Just nothing on here. Yeah, right. So I don't know. It's there somewhere. I've seen like a table in the docs somewhere, but it's anyway. Yep. Any other thoughts before we move on to the fallback handler stuff?
Another slice of pizza.
Yeah, seriously, we have so much pizza.
These are just like library methods,
These?
or are they? Yeah, I can
Mhm.
tell if they're library methods or they're just like running over there.
Yeah. So, I just wanted to show you like the interface for the different contracts. So, man, I really wish I had like a. So if we go to Gnosis Safe actually real quick, and if I just like try to spin up like a sample safe, I'll connect on Gorley, and I'll create a new safe. So I'll set like a 1 of 1 threshold with only me as the owner, and then I will deploy this safe. So, okay, all right. Here's an address finally, for crying out loud. So this is the Gnosis Safe proxy factory, and if you notice, all these transactions, people do create proxy with nonce, create proxy, and if we look at these different transactions and observe the data field, we can decode this input data. And so we can look, yeah, hey, here's our singleton address. So they're using this is the salt nonce. This is the singleton address, and this is the like initialization data, which will set up themselves as the owner, and the rest is mostly zeros. But so for example, here is the master copy on Gorley. This is the address. Looks like, you know, I don't know if there was like an initial like create transaction, but yeah, it probably costed quite a bit of gas to deploy this contract, as it's pretty big. So that's the master copy address. So you can go and look at all the transactions that have ever been transacted transaction to this Gnosis Safe proxy factory, and you can see like what input data they pass in, and then different different like initialization parameters. Also, like side note here, anyone can use this proxy factory to generate their own Gnosis Safe. So you never want to like send a Gnosis Safe ether beforehand and then try to deploy a proxy factory to it, because you'll get front run. So anyone can see that, hey, like if you send ether to an address that you know is going to be your Gnosis Safe in the future, because you've selected a certain salt nonce as like a deterministic deployment address, anyone can, it'll just look like you're transferring to an unused externally owned account. But then if you come to the Safe proxy factory and you try to deploy a Gnosis Safe that resolves to that address, someone could pay more gas to put that exact same transaction right in front of you, and perhaps like add themselves as a signer, and then like grab all your funds beforehand. So that's just like it's a weird caveat. Just like always use either do it atomically in one transaction, or use the Safe UI to create these like executable transactions. But yeah, so like if you notice in these different like transactions, if we go to the data field, we'll have what's called let's look at the from address. The from address is here. Interesting. Yeah, so most likely one of these addresses here is going to be the fallback handler. So something for you to know is that like it's probably going to be this address. Every single address on every single Gnosis Safe is deployed with what's called a compatibility fallback handler. And what that does is it's like an upgradable way to handle token callbacks and any sort of like forward upgrade path. So if it's not that either. If you've ever used something like, I think an early version of CoinShift did not deploy Gnosis Safes with the compatibility fallback handler, so it couldn't actually receive ERC20 tokens. Sorry, I can't find the compatibility fallback handler, but it's in here somewhere. So it's a way to handle like token callbacks. It's a way to handle EIP 1271 signatures, message hashing. It handles all these methods, right? So really, when you call the Gnosis Safe with any of these methods, it's not going to interpret that on the Gnosis Safe itself. It's going to interpret that on the compatibility fallback handler. So like that's how Gnosis Safe works. Is it has like a generalized fallback slot. So if you do a call to a Gnosis Safe with a method that it doesn't recognize, it will try that method at the compatibility fallback handler. So this handles like Gnosis Safe 1.2.0 and below methods, and also like EIP 12 itself, 712 signing, ERC 1155 tokens, and ERC 721 token callbacks. So it's how like safes can handle NFTs. So if you're handling the deployment of like Gnosis Safes yourself, you always want to make sure that you deploy with a compatibility fallback handler as well. So yeah, I guess just to kind of summarize at this point, like signatures are gathered up off chain. Like so with the Gnosis Safe architecture the way it is currently, signatures are gathered up off chain. You send them to like a Django server. They gather those signatures off chain, sort them, handle all the notifications, handle the notifications to your mobile phone if you have the Safe app, and then we'll handle your signing of those with the private keys. And then we'll eventually allow anyone to kind of gather those signatures off chain and pass them to the smart contract on chain for them to resolve as an execution. Another quick note, you can estimate the amount of gas required to execute a transaction by calling required TX gas. That's like a method there that will revert with the amount of gas it will actually take to execute a transaction on behalf of a safe. So it's like very good for estimation off chain, or you can use it in a try catch block on chain in like a smart contract to like figure out how much gas something needs to use. Third point here is if the safe transaction service ever goes down, you can actually manually sign transactions by calling get transaction hash and then calling approve hash with your signing wallet. So you can manually go to the Gnosis Safe and say, hey, I as a signer approve this hash. And that's a way that you could do it if the safe transaction service ever kind of goes down. There's like the convenient way to do it, but then there's the decentralized way to do it. Third, get message hash for safe is the encoded signed message for safe. This is like comparable to the ETH_sign method of a Gnosis Safe. Next note is each safe deployed via the Safe UI is a proxy contract, meaning its cost is minimal. We talked about this. And then also there's, just so you know, if you're making modules have a lot of boilerplate as well. So there's a module factory to deploy new modules, and like the gas cost is like astronomically lower. Like it was somewhere close to like 0.9 ETH to deploy a module for our kind of smart contract system that we were doing at Bulla, and then we switched to the smart contract module factory, and it uses this proxy system, and it's pennies on the dollar. It's like way less, and you can do it deterministically. So would recommend there. Here are just some random ideas, like a contract can validate a safe's EIP 1271 signature given a sorted array of owner signatures. So like, for example, you could say that a EIP 1271 on-chain signature is verified by, and I'll show you this on-chain, it handles that, and this probably only makes sense if you're used to the EIP 1271 spec in general. But like if another smart contract is asking if this is valid, then you can pass an array of owner signatures that were collected off-chain instead of asking for this Gnosis Safe to sign something on-chain. So you can actually you could gather up a whole bunch of owner signatures above the threshold. So as we can see here, it uses the check signatures method. And if you gather those signatures above threshold off-chain, then they will resolve on-chain as a valid signature from that Gnosis Safe. And so I'm trying to think of like where that could be useful is you could do like private signing off-chain and gather up signatures on behalf of a DAO, but using only the DAO signatures. And so that could be useful for like OpenSea sales or other like EIP 1271 signatures. It's just something that hasn't been implemented yet on the front end, which is kind of cool. You could also write like a custom fallback handler to implement like custom function calls and storage rights if you wanted to, because you could ask your Gnosis Safe to deploy like a custom handler that would accept like a whole bunch of different things. So say there's like a new token standard that you want Gnosis Safe to be compatible with. You could write your own compatibility fallback handler to handle those. I also wrote this for like a DAO house presentation. So like I was saying that like you could install a trusted guard that performs an action on a ball module, like for every transaction as well. Yeah.
What's ball?
It's yeah, right.
Contract for executing anything off of
Yeah, it's a DAO that it's like a DAO framework that introduced the concept of like rage quit, if you're familiar. Yeah, Moloch. Yeah, so Bal is like V3 of Moloch DAO. Yeah. Yep. So here are just like some links to the repos. I've got the flattened contract repo here. That is the repo called Safe Talk that we were looking at here, which has kind of that reference sheet for the flat safe contract, and both the flat safe and the compatibility fallback handler. So like any function that you can find Control F on in here can be called on a live Gnosis Safe in production. And then Foundry test tools, which I can talk about in a second. but just like first wanted to see if there were any questions.
What was the modifiers? What did modifiers do again?
Yeah, we can take a look at that in a minute. I'm not super familiar with modifiers, but they're like modules for modules. So like you can install a modifier on your module, I believe, that will route transaction execution to that modifier before it goes through the module.
So like some third party creates a module and then they provide functionality.
And then I could write a module. I could write a modifier for that module that says we can only use this module once a day. Or we can only push, 10 ETH or 1,000 USDC through this module a month.
Yeah,
Or like
do the ball kind of thing.
exactly.
Yeah.
Exactly. For those of you who use Foundry, I wanted to show off this repo real quick that I put together. So like I wrote this thing called Safe Test Tools, and it's a friendly wrapper for deploying safes, executing EIP 1271 signatures, executing transactions, enabling and disabling modules, and you just simply call setup safe. So like beforehand, this was the boilerplate that had to be written for like deploying an address on chain. You had to set up owners. You had to deploy a new compatibility fallback handler, a new singleton, a new proxy factory, a new message lib. You would have to then deploy a master copy, set up that master copy, execute a transaction data, like say I wanted to send Alice half an ETH. I would have to write that massive like exec transaction call itself. I would have to sign that with a private key, and then I'd have to exec it itself. And so like there was so many steps to this is what I wanted to do, right? Is I just wanted to like send Alice 5 Ether, but I had to do all these different things to get there. And so I wrote a Foundry module that allowed you just to do this, right? You deploy a safe instance, and then you just say safe instance.exec transaction with the minimal amount of parameters that you need. So I want to, from the safe to Alice, 0.5 Ether, no data. And then I assert that the balance afterwards is 0.5 Ether, so she received it. So like, this is all you have to do is you wrap these safe instances in like a safe instance lib, and then you could have access to these like 2 value and data fields. All I have to do is call setup safe, and then it's like a 2 out of 3 safe that gets deployed based on the like default hard hat accounts if you've ever used that. So like hard hat account 0, 1, 2, and 3 are signers, and I labeled them as like signers 0 through 2. It gets deployed with an initial balance of 10,000 ETH. There's some like different wrapper methods. It stores the owner PKs, the owner private keys in an array, and what it does is it sorts them by computed address before they're actually deployed onto the safe. So you could pass any array of private keys. So like say your private keys in advance, I could just put my private keys in an array, deploy safe, and then be able to use that in like a live testing environment or like a forked environment, and do things on behalf of Gnosis Safes. It's deployed with a compatibility fallback handler, and this is the API. So I could use like a really like basic API or a super verbose one. I could enable or disable modules. I could ask it to sign transactions. I could like manually increment a nonce, or just have my safe actually sign a transaction. So it's kind of in to do, but if you use Foundry and if you want to test stuff against Gnosis Safe, like feel free to use this library. I'm trying to like get it out there a little bit more.
Can you build transactions with that? Like say like I want to send 5 different sums to 5 different addresses.
Yeah. So you could just write these lines one after another. So you just write exec transaction, exec transaction, exec transaction, and you could do whatever you wanted.
With that, I'm thinking of a time when I was with a group and like we had to grab some some funds to send people who had totally fucked up the series of transactions, but like they all did it the same way, and there was like 8 people. We had to send them, but different sums to these different 8 people. But if we didn't want to like sign 8 different transactions.
Yeah, so this is just like a test tool specifically. It's very gas inefficient, but it just batches these things so you can use them in Foundry. What you would want to do is you would want to build a multi-send transaction. So if you go to Gnosis Safe, Gnosis Safe IO, you open the app. If we went to my test safe here, if you go to apps, you could use this app here called Transaction Builder. And what you could do here, oh man, this is going to be super rough. Yeah, this is pretty gnarly. Actually, yeah, you could just say this. So like, I'm adding 0.05. So like, say these are different addresses, right?
Okay.
But so what I could do is, what I'm doing is I'm creating a transaction batch via the multi-send library. And I can organize these, and this is just like a plain ether transfer from this Gnosis Safe to this address. And so, like, say this one's 0.1. And so if I create this batch, first of all, I can simulate it to see like if it works, right? And then I would send the batch to the Gnosis Safe, and I could actually decode these transactions, say like, okay, so here we go. I'm gonna send, 0.5 Gorilla ETH to this person, this person, this person, and then like I could send it to the rest of my signers. So like I would sign off on this as a Gnosis Safe, and here's that verbose kind of EIP 1271 signing. MetaMask sucks. Yeah, so this is like all the data that I'm signing off of. This is the operation. It's because it's a delegate call to the multi-send. And then I'm signing it off here. So if I go to view transactions, the rest of my users will see like, okay, I'm actually trying to do this transaction. So I'm doing a transaction to the multi-send contract, which will allow me to do these 4 transactions in a row, where I send 0.5 Gorilla, and then me and all my friends can like execute that transaction, and then it will go on chain. And that's a way that you can like build these transactions from the Safe UI and then execute them on chain. So that puts us at like an hour, 20 minutes. How's everyone feeling? How's the brain fatigue? We could pop into some code, or we could just do like QA, or we could like, I don't know, call it. Up to you guys. But that's all I had prepared. But that gives you like a 20,000 foot view of Gnosis Safe, the different contracts in the ecosystem, the different kind of gotchas. Like, who knew about the compatibility fallback handler? There's no docs on that. It's super weird, right? There's all this like lore baked into like how your Gnosis Safe actually works that's kind of very esoteric to get to. You've got that repo if you ever wanted to have like a reference sheet of like, hey, what functions can I call in a Gnosis Safe validly? These are all the contracts in the ecosystem. So yeah, I guess like up to you guys. If you guys had code you wanted to go over, that's all I had kind of prepared for today. Nice.
I had like just kind of a random question. So like the last DAO I was at, we just set up a a Gnosis Safe and kind of that was that. But
Mhm.
do you find yourself like regularly deploying Gnosis Safes or or is it kind of like a one and done sort of thing? 'Cause, like, what would be the use case of like setting up multiple? I mean, I know you can find ones, but I'm just saying like the DAO was just like set up without one and that was it.
Yeah, so like if you're a DAO and you set up a Gnosis Safe, like you would just probably set up one and then like opt in to like add and remove signers as necessary, or add and remove modules as necessary. It's totally up to you, you know? Yeah.
Because if you were like writing some kind of DApp to say like deploy a DAO, deploy your DAO, and you were able to know that. You were saying that like you use this information yourself for work.
Mm-hmm.
Yeah, for Bullet Network.
Yep.
Yeah.
Correct. Yeah, it's always good when you're building a protocol to, you know, like usually you test your smart contracts against externally owned accounts, but it's good to test your smart contracts against Gnosis Safes as well, because they're very heavily used in the ecosystem. And you want, especially when you're doing signatures, you want to make sure that your protocol is compatible with these EIP 1271 signatures, because like a lot of users, hopefully in the future, I mean, depending on how account abstraction goes, a lot of users in the future will hopefully be pushed to Gnosis Safes and like Argent wallets and other smart contract based wallets that will have to do 1271 signatures. So if you really want to bake in, and I have good examples of like what that looks like, right? Where you try to do an EC recover call to test for EOAs, and if that doesn't work, then you do a 1271 signature call. So you're allowing for both kinds of users in your smart contracts. And so this is a way to, ideally these safe tools are a way to do this, right? Like I could just call, I could create a hash digest, and I could call EIP 1271 sign on the safe instance in a test, and then like ask my Gnosis Safe to make a smart contract call like a EOA would, and then it would, then you could, then you know that your protocol works for both like EOAs and Gnosis Safes, and you just want to include that type of user. Like in the same way, that you test your front end for like readability and accessibility and like, contrast, and you can tap through the whole thing, right? It's like for...
I mean, that makes sense in DeFi, especially like, a DAO that's, has, they're like yield farming or something.
Mm-hmm.
And, the only way they move to different pools or whatever is through Gnosis Safe.
Mm-hmm.
Possibly.
Yeah, exactly.
Does like Party DAO use Gnosis Safe?
Party DAO. I don't know if they use Gnosis Safe. Probably do.
Anyway, just random. Interesting.
Most folks do. Either Gnosis Safe or DAO House, yeah.
Makes sense.
I don't think so. They do. I just know they do like group buys on things.
Mhm.
That's what I was thinking about. It's like they'll like buy an NFT, and then you'd be like, oh, I want to own some of that, and just give money to the creator. But I think they would.
That's cool. Fractionalized DAO ownership.
Yeah. Yeah. Any other thoughts? Anyone wanted to see any code or anything like that?
Yeah.
They use as what? Yeah. Yeah. So like, I'll show you for example in the code on our V2 contracts. Which are currently a work in progress. We're going to wait till we get funding to do an audit and everything. because audits are expensive. But for example, if we go to, I have like a whole way to handle like permits with permit lib. There we go. I have a whole way to handle permits based on signatures, so I could allow any smart contract to do things on Bola on my behalf if I generate a valid signature. And so this is all EIP 1271 stuff. But if I go to the actual signing part, okay, yeah, so here's what you can do. So for example, like I get the nonce of a signature, which is like necessary to prevent replay under all circumstances. So if you're doing signature stuff, always encode a nonce into the signature itself. Next, I get the hash digest of like what this signature is. So this is just like a 32-byte digest that is signed by the user. And then actually I use the is valid signature now function on the signature checker library that comes from OpenZeppelin. So OpenZeppelin is a great way to handle like compatibility for both EOAs and EIP like 1271 wallets. So like if I F12 on signature checker, never mind. Oh yeah, I'm using, okay, so here's the signature checker. This is by OpenZeppelin. It takes a signer, it takes a hash digest, and it takes the actual signature itself. So what it does is it tries to recover the signer using the EC recover flow. So it'll say like, hey, given the signer and a signature, is there a recovered address that signed this message? And there's also like an error too, like its own error type. So it says like if there's no error and the recovered signer is equals to the signer that we expect, then return true. This is a valid signature, right? Otherwise, if there is a signature, what it's going to do is it's going to do this is like a bunch of low-level code, but it's going to do a low-level call to the, so signer is an address, and signer has the member static call. So it does like a read-only call to the signer address, and it asks it, is this hash a valid signature? So this is like the EIP 1271 spec. It just, you pass the hash and the signature, and given the address, it will return like what's called like a magic value. So here's the EIP 1271 spec, but kind of basically, yeah, so this is like the magic value, right? So if you ask a smart contract, if you call this function, is valid signature with a hash and a signature, if it will be valid if it returns this magic value. If it returns this, 0x1626BA7E, then it's the smart contract telling you it's a valid value. So like this is a bunch of low-level code. But yeah, so the reason why this is called is valid signature now is because like unlike ECDSA signatures, contract signatures are revocable. And so like you could have a smart contract that signs a message at one point, but then unsigns it in the next block because they like, remove whatever on-chain verification is required to verify that message. But yeah, so like I guess TLDR is you can use this signature checker method on OpenZeppelin, and it's like a pretty gas efficient way to handle both EIP 1271 signatures in a way that's dynamic and handle EOA signatures too. Yep. Cool. So if that's any other questions? Sweet. Yeah, if that's all we had for today, I think so. Next deep dive is going to be like during Biddle Week in East Denver, most likely. So like we've done a couple different flavors of deep dive at this point. Would you guys want to see like another like deep dive into a smart contract system, or would you prefer to see like we could do like another CTF kind of challenge like we did over Christmas if you guys were there, where we went through the Ethernaut challenges and like walked through one by one, like step by step, how to do these like smart contract hacks. Yeah, we could do like more of like a presentation style like this. We could do a repo style where we just hop in a repo and get messy and it's more like discussion led, or we could do like a CTF. So what's everyone's flavor, right? Because this is like for us to learn. You like what?
I like Ethernaut.
You like Ethernaut? Cool. Plus 2 for Ethernaut.
Sure.
3.
Yeah.
Sweet. Okay. 4. Nice. You what?
Who's gonna send? Who really likes presentations? Somebody's a PowerPoint fan.
Microsoft
Not
Office?
on, not on this TV. Get enough of their word. Today.
Down for day, like if this is only my first time coming, but I'm always down for like going to a repo to learn something, build something, do something cool.
Cool. Yeah, I think I was trying something new with this whole like presentation style. I've done the last 2 of them like this, and maybe that was kind of a swing and a miss. So should we go back to just like doing repo style stuff? Is that more helpful, do you think?
It's
More-
hard to say because I feel like I always get something out of it. But-
Yeah, I don't think.
Yeah.
Okay.
But I like both. Like they're both.
Yeah, I'm
I like to learn by doing. Like Ethernaut.
Yeah.
Very exciting.
okay, cool. Yeah, like I won't be offended, right? Like that we're all figuring this out together, so
I
whatever.
mean, can we mix it up? Because I appreciated this. Now,
Yeah.
I'm gonna have to go back and take a look at your presentation and go through the repos, right? But
Right.
like this was not a waste of time for me at all.
Oh, cool. Sweet.
But
Okay.
I'd like to mix it up as well. So Ethernaut would be good. But
Yeah.
Sometimes throw some of this in.
Yeah, maybe we do like every other one, right? Like one where we're like getting out our laptops and like hacking on stuff together, and like another one where we're going through a little more methodically and like studying how they put together contracts. And
I think this is something I was talking to Brad about doing like some high level like 101 for like new smart developer stuff. I think Gnosis Safe is like it's such a ubiquitous thing that it's helpful to have that high level overview of. But other things like that, it's a more niche like protocol or something. I don't know that we would necessarily. We'd probably get more value out of getting into code to see how maybe they have a unique like way of solving some problem that's pretty common. Versus if you gave the overview of like Shitcoin X that launched last week, like
right.
we don't really need to learn about their overall structure because they might not be here tomorrow.
Yeah, true.
I think the other thing randomly, maybe not for next time, but in the future, is just some of the EIPs. Because like this is the first, it's so hard to keep up with all of them. And this
Oh,
is the
yeah.
first time I've really like even thought about 1271.
Right.
Yeah,
Um,
that's a good idea actually.
So yeah, because I've been reading through and like just so many.
There's so many.
Yeah.
Yeah, like a reference sheet or something, or like what are you thinking?
I don't know. Like even if we just like went into like 1271 for example, or one of them. I mean, we did a little bit tonight, but something where it's like, okay, this is like an important one, and let's go into it and talk about it. I guess.
Yeah, and how do we read one? Because there's like
Huh.
there's a whole protocol on how you read the IP.
Yeah.
We could start that one column with just like 5 or 10 most important EIPs.
That'd be sick.
And then we can like crowd favorite which one we're going to.
Mm-hmm.
Mix and match overview.
It's a good idea. Or like even like, yeah, BuzzFeed, right? Even like top 5 upcoming EIPs,
Yeah.
like that are like in the pipeline for like, because like 721, the NFT standard is here to stay, right?
Yeah.
But like, you know, account abstraction and like alt mempool stuff is like, you know, proposer builder separation. Those are all like very niche and upcoming, but like very important EIPs.
Yeah, that's I think too is like maybe not every single one, but ones that are like these are really important, and you can also learn even if they don't go through, like you learn more about the I don't know, sort of like how Ethereum works a little bit and stuff.
Mm-hmm.
Some of the problem sets.
Mm-hmm.
Like how do people handle this problem today?
Yeah, true.
But I'm just telling you.
No, it's good. I like that. Maybe we can do like Ethernaut for the next one.
Yeah.
And then go through maybe do like some EIPs in April, and then in March we can do I don't know, like a repo walkthrough, like an actual code walkthrough, and I'll have something for you guys to like all clone down. Something like that.
Does anybody have, I mean, obviously Denver's the big one. Does anybody have any like community announcements or needs or anything they want
Yeah.
Is everyone going anything?
Yep.
to? Are you allowed to not go?
Yeah, exactly. Who's not going? Who's not going?
Yeah. Come on, right?
I'm going to Terra.
It's like next month.
We're back to both. Yeah. I'm going to Terra.
Are there any other meetups where people do like do deep dive code?
I don't think so.
Fridays. The only one.
Yeah, this is the only one that got me out of the house.
Oh yeah.
Everything else I